about law of mass action and law of chemical equilibrium in proper way. So students, law of mass action. What does this law states? This law states that the rate of reaction is directly proportional to the product of active masses of reactants. What does it mean students? कि किसी भी रिएक्शन का रेट डिपेंड करता है किस पर? जो कंसंट्रेशन है उसकी कंसंट्रेशन ऑफ रिएक्टेंट्स है, मींस रिएक्टेंट की के एक्टिव मास के डायरेक्टली प्रोपोर्शनल है. एक्टिव मास देखो हमेशा ये पॉसिबल नहीं है कि जितने भी मॉलिक्यूल्स हमने लिए हों, जितना भी अमाउंट हमने लिया है वो सारा ही एक्टिवेट हो, ऐसा नहीं है. कुछ मॉलिक्यूल्स हैं, भाई मान लो ये हमारा रूम है, इसमें हमने गैस फिल की है, तो आपस में गैसियस मॉलिक्यूल्स क्या करेंगे? कोलाइड करेंगे. भाई कुछ की काइनेटिक एनर्जी कम हो सकती है, किसी की का ज्यादा होती है. जो मतलब इन सेंटर हैं, जो पार्टिकल सेंटर में होंगे उनकी काइनेटिक एनर्जी ज्यादा होंगी, वो ज्यादा एक्टिव होंगे. बट एक पार्टिकल है कि जिसकी भाई बिल्कुल कॉर्नर ऑफ द वॉल्स है, ओके, बिल्कुल हमारे रूम के कॉर्नर में है, तो वहां पर उसको मूवमेंट के लिए क्या है? प्लेस ही नहीं मिला, तो उसकी एक्टिविटी कम है. मीन्स तो लॉ ऑफ मास एक्शन क्या कहता है कि रेट ऑफ रिएक्शन ये डायरेक्टली प्रोपोर्शनल होता है किसके? प्रोडक्ट ऑफ एक्टिव मास ऑफ द रिएक्टेंट्स. मान लो आपके पास 2 रिएक्टेंट्स हैं, दे आर गिविंग अस products. Let us consider this is the reaction. So here reactant A and B. So students, rate of reactivity of A की रिएक्टिविटी का अगर हम रेट की बात करें कि ए किस रेट से भी स्लो करेगा, फास्ट करेगा, मॉडरेट लेवल से रिएक्ट करेगा, इसकी जो रिएक्टिविटी है उस वो क्या कितनी होगी, उसका क्या रेट रहेगा, वो डिपेंड करेगा कि इसके कितने, इसके जो मतलब इसकी कंसंट्रेशन थी, भाई इसका कितना मास एक्टिवेट था वहां पर, इसका कितना मास एक्टिवेट था. तो डायरेक्टली प्रोपोर्शनल होगा कंसंट्रेशन ऑफ ए, क्योंकि जितने ज्यादा मॉलिक्यूल्स होंगे उतना ज्यादा कोलिजन होगा, उतना ज्यादा कोलिजन होगा तो रिएक्शन का रेट भी क्या होगा? बढ़ेगा. रिएक्शन का रेट भी क्या होगा? बढ़ेगा. तो वो डिपेंड करेगा किससे? इट इज द डायरेक्टली प्रोपोर्शनल टू द कंसंट्रेशन ऑफ A, okay, or we can say active mass of the A, and rate of reactivity of B, it will depend on the active mass of the B, or we can say concentration. Clear or not? If combinedly I say then A plus B, okay, yes, giving us products. So according to law of mass action, overall rate of reaction, because in reaction both will participate, these both reactants are participating, so rate of reaction directly proportional, it is directly proportional to the active mass, okay. So it is the directly proportional to the product of active mass of the reactants. So here 2 reactants A and B, okay. So rate of reaction directly proportional to the product, means multiplication, product of the active massage of the reactants. This is the law of mass action. It is clear or not? Any doubt in this one? So students, after removing proportionality, we can keep any constant here. So this is the law of mass action. This is the law of mass action. And student, by applying this, we can express law of chemical equilibrium or chemical combination also we say. Chemical equilibrium. Equilibrium means reaction take place in both direction, in forward as well as in backward. And rate of reaction in both direction is rate of reaction in both direction will be same. Rate of forward reaction and rate of backward reaction will be same. Clear or not? So students, here if we are having one reaction A plus B, these are the reactants. Let us consider it is reversible reaction. Okay, so they are giving us C plus D, C plus D. So according to law of mass action, according to law of mass action, if I want to write, this one is the forward reaction in this way. If these reactants are converting in these products, then it is forward, and further these products are converting into reactants, then this one is the backward. So students, in case of forward, reactants are these? Yes or not? So if I want to write law of mass action for that, how can we write? Rate of this reaction will be directly proportional to the product of active mass of the reactants. Yes or not? So rate is equal to the, by removing this proportionality constant, I will put proportionality constant. Let us consider it is Kf. Kf means equilibrium constant for forward reaction. Equilibrium constant for forward reaction. Clear? A, B. Let us consider this one is 1. Then students, this is for forward reaction. If you want to write for backward, then what will happen? Here students, in backward means these are converting into this one. So here reactant will be this C and D. Here reactant will be C and D, because reaction is going to be in backward direction. So here reactants are these. So according to law of mass action, rate directly proportional product of the concentration of reactant, and here reactants are C and D. So it will be directly proportional to the product of active masses of C and D. So rate, by removing proportionality sign, we will put constant of proportionality. I can say Kb means constant for backward reaction. Yes or not? It will be this. I can consider this one 2. This is for backward reaction. But students, here I am talking about equilibrium. Equilibrium. What was the condition for equilibrium? Equilibrium condition was that rate of forward reaction should be equal to rate of backward reaction. So this one is the rate of forward reaction and this one is the rate of backward reaction. So it should be same. It should be same. So I can write Kf, concentration of A, concentration of B equal to Kb. I can write or not? So from here, Kf is equal. Yes. Kf concentration of A, B is equal to KB, concentration of C and A. It is clear or not? It is clear or not? From 1 and 2, I have written 1 and 2. And because rate of forward reaction should be equal to rate of backward reaction. This is the condition. This is the condition for equilibrium. Clear or not? Then students, Kf, if I take Kb, because both are the constant now, in this side, then it will be C D by. Take this one in this side. Okay. So both are the constant. Yes. I can write one constant at place of these. Clear? So students, Kc, equilibrium constant. Okay. At this is showing concentration, because here we are having concentration now. That's why. Then Kc is equal to root C. Sorry, concentration of C, concentration of D, A and B. This is the law of chemical equilibrium. Yes. Yesterday we discussed what was the law. Law is that equilibrium constant will be equal to the product of concentration of product divided by product of concentration of reactants. Clear, students? But if you have reaction in this way, A, B, means here these are the coefficients. These are the coefficients. Means how many moles are reacting here? Clear? These are the coefficients. Then we can write equilibrium constant in this way. A product of concentration of product is raised to power their stoichiometric coefficient. Its stoichiometric coefficient C. It's D divided by product of concentration of reactant. Reactants are A and B, their product. Each raised to power their stoichiometric coefficient. If coefficients are there, then we can write in this way. Clear or not? And if you have simple equation, then in this way. This is the law of chemical equilibrium. Any doubt in this one? Clear? Yes. Then students, if you are having reactants are in gaseous form, if your reactants are in gaseous form, then we can write law of chemical equilibrium in form of pressure also. In form of pressure also. Because gas will exert. Okay. So on behalf of their pressure, also we can write the law of chemical equilibrium. Clear? How we will write? In same way. You know very well. Pressure according to the ideal gas equation. I think in thermodynamics I told you about ideal gas equation. PV is equal to nRT. So P is equal to N by V RT. Clear? And concentration is number of moles per unit volume. That is the concentration. That is the concentration. Clear? Then students, I can write P is equal to C RT. Yes or not? Yes or not? I can write? Yes. So in same way, if you are having concentration only, and you are having this one equation, then you write equilibrium constant in this way. Their concentration product, already I told, raised to power their stoichiometric coefficient divided by product of reactants concentration raised to power their stoichiometric coefficient. One is this. But if these reactants and products are in gaseous form, then they will exert pressure. So how can we write? For that I can write Kp. At constant pressure I am having now. So this, I can write pressure of C, pressure of C raised to power coefficient. At place of concentration I can write pressure. Yes or not? Means which pressure exerted by product. Their product we will write in raised to power, we will write their stoichiometric coefficient divided by pressure exerted, product of the pressure exerted by the reactant, in raised to power their coefficients. Clear or not? Then pressure of C raised to power coefficient. Then pressure of D raised to power coefficient. Here instead of concentration we are having pressure. Pressure of A raised to power A. Then pressure of B. Clear or not? Yes. Now P. P is equal to CRT. Yes. P is equal to CRT. So here Kp is equal to, P means C, concentration. Here C is the concentration. So I can write in this way, concentration of C. Yes or not? Yes or not? In this way, concentration of C and RT raised to power their coefficient. I can write or not? Then I can write in a separate way, concentration of C raised to power C, then RT raised to power C. I can write or not? Yes. Yes. Then PC means concentration of C raised to power C, we will write RT because pressure is CRT. That's why RT also power I will write C. Clear? Then PD. D means concentration of D raised to power D and RT raised to power D. Then concentration of A raised to power A, RT raised to power A, concentration of B raised to power B, RT raised to power B. It is clear or not? Any doubt in this? Yes. Now, this one. I can erase this one now. You know about this concept? Yes. Here, Kp is equal to, I can write in this way, concentration of C raised to power C. With this one I can take D or C raised to power D. Here RT common, base if base same and power different, then and their product is there, then power will be added. I can write C plus D divided by concentration of A and B. I can write then RT, base same, power different. Addition, we will do addition if product we are doing. So this you can see C की power C raised to D raised to power D, A raised to power A, B raised to power B. This is equal to Kc. At place of this one, I can write Kc or not? I can write. So Kp is equal to Kc RT. If base is same, in division what will happen? Power will subtract C plus D, then minus A plus B. Clear? Here what is C plus D? C is the number of moles of this product and D number of moles of this one. So C plus D, total number of moles of a product. Total number of the moles of a product. So I can write Kp is equal to Kc RT del N. Del N means change in number of moles. Change in number of moles. Change in number of moles mean number of moles of reactants. Sorry, not reactants, product. Number of moles of products minus number of moles of these A and B. These are the reactants and A and so number of moles of reactants. So this one is the relationship between Kp and Kc. Any doubt in this one? Okay, first students, you should know about going to be hang. Not working, it is. Firstly, we should know about the law of mass action. So law of mass action is rate of reaction directly proportional to the product of active masses of reactant. Clear? If we know about law of mass action, then we can express law of chemical equilibrium also. Chemical equilibrium also. In chemical equilibrium, reaction take place in both direction, in forward as well as in backward. First we will write rate of reaction for forward direction, then we will write for backward. But at equilibrium, this rate of forward reaction and rate of backward reaction should be same. Okay, so we can put equal them. Okay, and after putting equal, up Kf by Kb, both are the constants, so I can take one single constant Kc here. Okay, and from here I am deriving the law of chemical equilibrium. According to law, equilibrium constant equal to product of the concentration of products divided by product of concentration of the reactant. Clear? If coefficients are also given, then you can write this equation in this way. Then if gaseous reactants and products are there, then you can write this law in form of the pressure also. But you know very well about the relationship between pressure and concentration. Pressure is equal to CRT. Okay, from ideal gas equation we can derive this one. Then by putting all values, finally we can derive relationship between Kp and Kc, and this one is the Kp is equal to Kc RT power del N. Del N is the change in number of moles. Number of moles of products minus number of moles of the reactants. Any doubts? Yes. Students, you know, this constant also had some characteristics. This constant also had some characteristics. First thing, now you know very well how we write this one. First one, students, it has a fixed value. It has a fixed value. At particular temperature. Particular temperature. At a particular temperature, value of constant will be same. But if temperature we are going to change, then its value also change. Means it depends on the temperature. But students, value of equilibrium constant is independent on concentration of reactant. It is independent. It is independent on concentration of reactants. Rate of reaction is depending on concentration of reactant, but equilibrium constant is not depending. Clear or not? So students, some more characteristics are there for equilibrium constants. We will discuss about them tomorrow. Any doubt in this concept? Okay, so thank you. Have a nice day.